Okay, this is 9.2. We're going to be talking about systems of three equations, which I know you've done before in Algebra 2, but we're going to get into a little bit more detail and also refresh your memory of how we solve these. So first I want to talk about kind of what this looks like physically. So our three variables are x, y, and z. We can think of x as being right to left, y as towards us and away from us, and then z as up and down. So we've kind of got this three dimensions going on, right? So if you have one solution, then that would be a situation where you have three planes intersecting in a single point. That would be one solution. Infinitely many solutions would be where all three planes cross at a line. So it'd be infinitely many solutions. These figures are all different situations where you have no solution. So obviously this one, none of them are even touching, so it's obviously no solution. These, they're crossing, but there's no point where all three cross at the same place. So that's why there's also no solution. All right, so when we have three variables, we need three equations to solve. So it's always three equations, three unknowns. The number of equations has to match the number of unknowns. If I had three equations and only two unknowns, then I would have, no, switch that, sorry. If I had three unknowns but only two equations, then I wouldn't have enough information to solve. If I had three unknowns but four equations, then I would have either extra information. That fourth equation would be superfluous. It would give me information that I already have, or it would contradict the other equations, in which case it would be unsolvable. So an extra equation is either superfluous or it's unsolvable. So the only way to guarantee that you'll definitely be able to solve is if you have the same number of unknowns as equations. This example is really just talking about if you're given this triple. So remember, we have three unknowns, so it's an ordered triple. If you want to know if that's a solution, you're gonna just plug in these three x, y, z, right, into the three equations and see if you get true statements. You do in this case. This is plugging in the first equation and second equation, third equation, and they all come out as true. So that is in fact a solution to the system. In the next video, I'm going to do this example 2, where I'm going to talk about step-by-step how we solve systems of three equations. But before I do that, I want to talk about what it looks like when we have no solution and infinitely many solutions. So no solution would be, something like this, where we're going along and we get to a point where we have 0 equals 2. So it's just like with two equations, two unknowns. If you get to a point where you have a contradiction, that's going to be no solution. So a little bit more interestingly, if you have a situation where you're eliminating a variable, trying to eliminate a variable from two equations with three unknowns, and you get 0 equals 0, you generally you would think, oh, I got 0 equals 0, that's infinitely many solutions, that's all I can do. But it turns out that just because these two equations, when you added them together, gave you 0 equals 0, doesn't mean the other equations would do the same thing. So you can actually get a dependent solution. where you end up finding a solution where the other two variables are based on one of the variables. So you couldn't, in this situation, you weren't able to find out anything about x, but you were able to find x and y in terms, y and z in terms of x. I'm not going to require that you do this, but I want you to be aware that this is something that can happen. So essentially, you have, you don't know anything about x, but you do know y and z in terms of x, if that kind of makes sense. So it's still infinitely many solutions. It's just that your solutions, you have some restrictions on those solutions. You can think of your solution as being a line or a plane instead of, basically it's a line, right? Your solution is essentially a line instead of every combination ever. Yeah. So anyway, in the next video, I'm going to do some actual examples of solving. And so hopefully that will refresh your memory on all of that. Okay. I will see you guys in the next video.